Okay, I guess we are live now. Hi guys. We'll just wait for a minute and then we can start today's class. Okay, so it's 8. Let's get started. So, hi everyone, welcome to Cracku. Today's session is on DI. What DI essentially means is data interpretation. So, if you have seen the IIM Bangalore format, you would have seen that the 30 questions are allotted to quantitative aptitude and data interpretation. So, what we can expect in data interpretation, those kind of things we will be discussing in today's class. We will then look into a few questions, and yeah, if you guys have any doubts at any point, feel free to drop a text. Okay, let's get started with today's class then. Yeah, so before we begin, today's class is on DI basics. Coming classes, we have classes scheduled for matrices, determinants, calculus 1 and 2, where essentially we will be covering everything from the basics. So if you are someone who doesn't really know a lot about what matrices or determinants are, or have never really studied calculus, that will essentially be helpful for you, because everything will start from scratch there. And these topics we feel will be very important for the IIM Bangalore UG test, in the sense that this probably will be the topics which essentially differentiate you from the rest, if you are good in these topics, because the other topics, they are somewhat generic, more or less everyone would be comfortable with them. But if you can master these topics, matrices, determinants and calculus, then it gives you an edge. So definitely join in for these classes. The schedule is also available, you can go check it out there. Yeah, and also our free mock tests, 5 free mock tests curated specifically for the IIM Bangalore UG test. You can go check out our website, cracku.in. There you will find all the free resources that you will need for this exam, IIM Bangalore UG mock test, IIM Bangalore UG test. And yeah, we have resources for all the other exams also. So if you're someone who's preparing for IPMAT, you can still go check us out, because the syllabus we are thinking will overlap a lot. So go check us out there. We have daily targets for IPMAT. Everything is free, available for free on our website. So do check it out. And yeah, lastly, we also have a WhatsApp group, a dedicated WhatsApp group, which is for all the support that you might need in your preparation. We are there to answer that. The faculty, me and everyone else, we are available there all the time. So if you guys have any doubts regarding any topic, or if you guys cannot figure out something in the cracku.in ka site, if you're having some problem there, you can obviously reach us out. And also it helps because you essentially be a part of this group, be a part of this ecosystem, where you are with the like-minded people, all of whom are preparing for IPMAT and IIM Bangalore UG. So you guys can have discussions based on topics and all. That peer bonding essentially helps a lot. So that is one of the more important factors why you should be joining our WhatsApp group. Okay, so that being said, let's get started with today's class. Are we allowed to use calculator in the mock test? Yeah, I think on-screen calculator is given, so that won't be a problem. Good evening, all-rounder. Okay, let's get started with today's class. So yeah, first thing, the session objectives. So essentially, what are the things that we are planning to discuss in today's session? We will essentially understand different types of data representation. And data essentially is something, if you are preparing for the IIM Bangalore UG test, data sciences economics, or even for IPMAT in BBA, statistics and data interpretation is a big part. So these are the topics which essentially help a lot when you even start with your coursework as such. They help a lot. So data can be represented in many ways. They can be, there can be a table like, the ones you see in Excel. Essentially an Excel is a table only, right? So uh, it can be table. It can also be represented visually, like there can be charts, there can be diagrams which represent data. So we'll discuss some of the more common things that come in exams, and we'll see how we can extract relevant information from them. As in, if a chart is given to us or if a table is given to us, we can like look into the questions and understand, okay, instead of computing for the entire thing, we can essentially pick this part out and just finish with our calculations. So we'll discuss strategies like that as well, and applying calculations, because many times although they have a calculator, but it can be tedious and tiring for you to like use the calculator. So it's always better if you can finish it on your own. That's anyways better. So yeah, that being said, let's get into the topics. What is data interpretation? So we'll start from the beginning. So what is data interpretation essentially? So data interpretation means reading numbers, as we discussed, reading data, extracting numbers, interpreting trends. Trends as in data tells a story, right? Every number that you have in a chart, that tells something, like why it is there. So those trends we will try to interpret. That is what we discuss in data interpretation. And answering questions, obviously from an exam point of view, we need to answer questions, right? And what are the most common DI formats that we see in exams as such? We have tables. There can be tables where they're giving all the data, or there can be certain cases, where their table has some missing values. As in, not all the values are given, some values are missing, but they give us clues for us to figure out, indirect clues essentially, for us to figure out what should be there in the table. So those kind of table questions we can expect. There's something called bar graphs, there's something called line graphs, there's something called pie charts, and caselets. So these three also we will be discussing. I think most of you are somewhat familiar with the idea, like what these are, but anyways, we'll just have an overview of them as well. Caselets can be in paragraphs. Instead of actually giving you the data represented as a table, they are giving it to you as a paragraph. This is, although like somewhat not that common, they usually supplemented with a usually they will provide a chart or something. So yeah, let's get started then. Okay, so this is a question on tables essentially. So table, this is like a very simple, easy table. There's not much to discuss with tables, right? A table question is essentially what? Like this is one of the lists. So here we are given grains of items and value of exports in millions. So, and we are asked what percentage of the total import is the value of grains. So this is a fairly simple question. Here what we need to do is percentage of the total imports. So we need to have like the total import, and then we need to have the value of grains times 100. That is essentially what will give us the answer here. The value of grains we know is 600, and the total imports, this we can just add this up. It's given 5, 10, 1. Okay, so this is 33,000. So the value will be 600 divided by 3000 times 100, which gives us 20%. This is like a very simple idea about what we can expect in tables. There can be other questions also, we'll discuss about them. But now let's get started with the charts essentially, because tables we understand. Tables, and even for charts, what we do while solving the questions is we will interpret the chart into a table first and then move on. Because when we have a table, it's easier for us to compute, it's easier for us to understand what it is, what is not. Charts are better for like a visual component when you're like making a presentation, let's say. Tabhi a chart might seem very nice, but for our personal sake, we always prefer tables, right? So now let's get into understanding what these charts are. Let's start with the bar chart. Let's start with the bar chart. What is a bar chart? Essentially, it's a rectangular bars to compare values across different categories. So a chart something like this, where we have bars, and these bars are corresponding values we have for them. That is essentially that. So if we have a table, let's say x and y, okay, and we plot let's say y this side, and for x, instead of using points, we are erecting bars saying ki let's say for 2016 this is up to 200. Then instead of just plotting it as like 2016 comma 200, we are representing it as a bar. So a bar chart looks nice, and that is why we use bar charts. So they can be used to compare values across different categories. So a bar chart can be single bars, as in like for one single entity we are given say values for 2016, 2017, 2018. Or it can also be something like instead of just one company, we are given 3 particular companies, and all 3 of them ka 2016 ka, 2017 ka, 2018 ka, and then we'll use like different colors as such, so that we can differentiate ki this is for 2016, this is for 2017, like that. This is for company A, this is for company B, all of that we can do that. Bars can be horizontal like this, or they can be vertical as well. Like instead of giving building like shapes, they are giving us something like this. Well, that doesn't matter, right? Because we are essentially just something which is like this, we are flipping it to be like this. Essentially how we read it, how we understand it, that remains the same. And why is it useful? It is useful for showing comparisons. Like when we need to compare, let's say 2 companies ka revenue for A and B for 5 years. So company A and B ka revenue for 5 years we need to compare. Tabhi a bar chart comes in handy, because just looking at it, we can just say ki okay, acha, here it was bigger, then it went down or something like that. Let's try to understand how to read a bar graph. Yeah, so here we have a bar chart. The following bar chart shows the scores made by 4 teams in a tournament. So we are given team 1, team 2, team 3 and team 4, and based on the chart we can say that there have been 2 rounds. There has been a round 1 and then there has been a round 2. So what we do when we have a data set something like this, the first thing we do is represent it in a table. So what we have here, we have 4 teams, right? So we can just write team. We have 1, 2, 3 and 4, and then we have a round 1 and a round 2. Okay, simple like that. All the attributes, we're just representing it as a table. Then let's try reading it. So when we see this side, this axis, we understand there's 0, 20, 40, 60, 80 and 100, and each line corresponds to 2 units. So see, like from 0 to 20 we have 10 lines. So that would mean for 20 we are using 10 lines, which means that each line is a 2 ka value. So here for the first bar, for team 1 for round 1, the bar rises up to 20 to 24, right? Because it's touching after 20 2 more lines. So that would mean ki the value for team 1 for round 1 is 24. Pretty simple, right? For round 2, team 1 goes from 80 to 82, 84, 86, 88. 88. Similarly, let's read for the other teams also. You guys can comment in the chat box ki like for team 3 and team 4. Team 2 is 40, so 40 say 2 steps niche, so that will be 36, and round 2 we have 20, 22, 24. For team 3 we have 1, 2, 3, 4, 5, which is 10, and for the second round it's 40 say 4, so 36. Team 4 we have 40 say 1, so 38, and 60 say plus 1, so 62. So this is how we essentially read a bar chart. After reading this, there will be some questions. They might ask us about something, so that we will do according to what the question asks. But usually it's like once you've figured out the table now, then the questions that will follow, they are not that difficult. The questions, they might ask, some direct value from the table, or they might ask something like, find the average for this, or find the ratio of this value to this value, or like if this was that, all those questions. So we'll discuss about them. We have some sets lined up, some pretty interesting sets to discuss in today's class. Now we have one question on bar graphs. It's, you have to essentially read the bar graph and then answer the question. It's a pretty straightforward, pretty simple question. So you guys can try this out. It's a fairly straightforward, fairly simple question. Okay, Rishabh has given an answer. The other guys also, please try it out, because when you start with trying out the easier questions, then eventually if you build your difficulty to like a harder level, that transition is much more smoother than if you just suddenly jump into harder questions, right? Yeah, Rishabh has given an answer, Spider has given an answer, Anusha, Shipadi, Dunno, Niharika. Okay, many of you guys have given the answer, and all of you are correct actually. Let's get into seeing like how we can essentially solve it. So we are told that the following is a bar graph: ratio between the number of vehicles sold by XYZ in 2013 and sold by ABC in 2016. So what this tells us, like, always in case of DI sets, it is always advisable to look into the question first, see what the question is asking, because now for this particular question, if I went on to like, read the entire chart, that would have taken some time. But in the question they are asking ki vehicles XYZ in 2013 is 1 point and ABC in 2016. Only these two values I need to read here. So let's just read these. XYZ in 2013, XYZ is the light blue color. XYZ in 2013, we are given it's 1516. And ABC in 2016, this is given as 1012. So the ratio will be 16 by 12, which is 4:3. Pretty simple, right? Pretty simple, pretty straightforward question. Let's move on to the next kind of chart. We have something called the line chart. Now this, as someone who has studied statistics, I can tell you that this is something which we use a lot in data analytics and statistics. This chart is essentially some chart where points actually connect the straight lines to show the trend. So there's something called time series data. We will not get into those things, but essentially the thing is, if something is changing over time, so when something is changing over time na, so tabhi instead of just plotting the points like this, we don't really understand what it is, right? But instead, if we just join them in a line, we can say ki, okay, acha, theek hai. So the demand, let's say, for something has gone up, then gone down, again gone up, but overall it has risen, right? Overall, if you see from here to here, it has risen. So these kind of things we can very easily determine from line chart. Line chart, x-axis normally represents time. The time is usually plotted along this side, and the y-axis shows the measured whatever attribute we are measuring. Sometimes it can be anything essentially. It can be like something so random as like, profit from to something like let's say the number of cars traveling through this road, or like the percentage of smoke exhaled by a car. It can be anything, very random, anything it can be. And it is ideal for understanding trends like the rise and fall, stability, and all of that. So this is a line chart, essentially what it is about. Let's see how it looks. This is how a line chart looks. So if you see this, this one shows the profit of two companies over different years. Okay, so we understand that for this company A, the profit has remained somewhat constant. It has risen a little bit though, but for B, we can clearly see that it is going down. Now, if instead of these lines, we were just given 8 random points, for us to understand what the hell is going on, that would have been somewhat difficult, right? So that is why line charts can be helpful in many situations like this. Reading it is pretty simple. We are given company A and B and 4 years, right? So let's just write it. We have 2008, we have 2009, we have 2010 and 2011. Two companies A and B. So for A, 2008, we have something one. Okay, so let's just understand what lines we have. So 0 to 1, we have 1, 2, 3, 4, 5 lines. So it means that every line is a 0.2. So for 1, in 2008, we have 1.246, 1.6. The next point is 3.4. The next point is again 1.4. And the last point for A is 2.4. Right. For B, we have for 2008, it's 4.2. Then we have a 3, okay, it's less than 3, so it's 2.8. Then we have a 3.246. And finally, we have a 1.8. So this also, reading it is not that difficult, right? Pretty simple, pretty easy to read. Now let's see a very easy question on line charts, where essentially you have to read the chart and answer the question. Try reading only the relevant data in this case also, okay? Yeah. Anusha has answered. Ayati, don't know, all of you guys are answering. Yeah. It was a simple question, right, guys? You let me know if you found it simple or like, a little bit complicated something. Give feedbacks for the questions, definitely. Okay. So in this question, we are told what is that? Okay, let's read the question. It says, study the following table. Okay, the below chart shows a comparison of scores between two teams from first over to 20th over. Okay, so we are given 4. The overs have been segmented into 4 parts: 1, 5, 6, 10, 11, 15, and 16, 20. The question asks, what is the difference between score of team A in 6 to 10 overs and a score of team B in 16 to 20 overs. Okay, so for 6 to 10, the score of team A, which is the dark blue color, is given by, okay, and first let's understand what each line is. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 lines. So each line is 2 points. So for 6 to 10, 6 to 10 for team A, we have 60, 62, 64. And for team B, for 16 to 20, we also have 64. Okay, so here, without actually even having to look at the values, we could just identify the points, like this was one point, this was the other point, and both of them are essentially on the same line. So we can say like if the difference is being asked, that has to be a 0. So option C should have been the correct choice. All of you guys who answered were correct. Okay, let's move on to the next kind of chart that we will be discussing today. The pie chart. This again looks very nice. It's like represented as a circle where all the divisions are made. So a circular chart, essentially it's divided into slices, and each slice represents a proportion or percentage of the whole. What I mean by that is let's say this is the circle, and this is a 90-degree angle, let's say. Then if it is a 90-degree angle, we've studied this in circles, right? If it's a 90-degree angle, this would mean it's 1/4 of the area. So if 1/4 is 100, this part would be 25%. Similarly, if this was let's say 30-degree angle, then this part would be what? 30 by 360 into 100, which would mean it's 8 point something percent. So that is the thing, sometimes they will give you these percentages directly, like 25%, it might be 20%, but whatever it is, always it will add up to 100. And sometimes they might, just try to test you guys and see instead of giving percentages, we'll give angle values. So it's very simple. If the angle value is given, you just divide the angle by 360, because 360 is the complete thing, and you multiply it by 100. That will convert your angles into percentages as such, right? So slice is proportional to the value it represents. Yeah, so it usually gives data as percentages, right? And then they will also mention what is the total. So like here when we write 25%, it means 25% of the total. So if the total is say 100 rupees, then 25% is 25. But if the total is say 200 rupees, then the 25% is 50. So based on the total, the absolute or the actual value might vary. So these are what we call relative values, or like percentages or ratios, where the actual absolute value is not given. So we essentially need to convert it. So let's look into a chart and see how it looks. So here we are given something. We are given the total number of students is 3 lakhs, and we are given 4 colleges A, B, C and D. So how we can read this? So we are given the colleges A, B, C and D. Let's note down the percentages first. A is 35, B is 20, C is 30 and D is 15. One thing you'll notice is if you add these up now, it gives a 35 plus 15 is 50, plus 20 plus 30 is 100. So it is a total. If it were a case like you add these 4 up and it's not adding up to 100, it would mean that there is some other component which is essentially missing from this chart, because all these percentages, because they're representing one whole thing na? So it is the 100% of the thing, so the total always has to be equal to 100. Any questions in this? No, I don't think so. Okay, so now that we know the percentages, and we have the total is 3 lakhs, right? So 3 lakhs is 300,000. We can essentially use the calculator here. 35% means what? It's 0.35 You multiply it by 3 lakh, that gives you a 105,000. Similarly, next we have a 20%, so it's 0.2 times 3 lakhs, that gives you a 60,000. A 30% will be 0.3 times 3 lakhs, which again, you don't really need to use the calculator as much, because 0.3 is 30% is 0.3, and then if you multiply it with a 3 lakhs, 1 0 gets cancelled out, and 3 times 3 is 9, so you are left with 4 zeros, so it will be 90,000. And the values are also pretty like nice given, right? It's 35, 20, 25 and 15. Instead, if it were given something like 17% or like 22%, something like that, which is not that easy to calculate, tabhi it is always advisable to use the calculator, or if you can figure it out on your own, that's so like well and good, but then you can always go for the calculator. The last value is 0.15 times 3 lakhs, which gives us a 45,000. Now one thing we can check is when we add up these four, so 45,000 plus 90,000 plus 60,000 plus 105,000, this adds up to 3 lakhs. So always, because this is a part of a whole, so always it will add up to the total only. The total was given to us as 3 lakhs. So this is how we essentially read a pie chart. Like every other diagram based chart, we'll first convert it into a table and then move on with the operations as such. Now we have one question on pie charts, similar to the two before. Simple questions, just for you to understand how to read a pie chart. So try it out. Here, one thing to note is they have not given the total value as such. They've given a difference between the third and fourth quarter. So first we will actually assume the total to be something, and then we'll calculate here. Okay, let's see how we can essentially solve this. So we are not given the total value, right? So let us assume that the total is 100 T or 100K or something, whatever. Why we are taking 100? Because see, the values are given 26, 25, 29%. So if it's percent, 29% of the value 100T will essentially be 29 by 100 times 100T, which will essentially leave us with 2090. So all this calculation we don't need to do. So we can just say it's 100T, and then we can move from there. Okay, and one more thing here, like for the third, second and fourth we are given. For the first quarter we are not given. So what will be the value of the first quarter? Let's just write it down. Q1, Q2, Q3 and Q4. For Q4 it's 29. For Q3 it's 26. For Q2 it's 25. So when we add these up, so 25 times 50, 51, 75, 4. So it will be 80, right? So if it's 80, so Q1 has to be 20. So if the total we are assuming to be 100T, that would mean Q1 is 20T, Q2 is 25T, Q3 is 26T, and Q4 is 29T. Are we clear on this? So now, when we have this, now let's look into the constraint. We are given that the difference between the third and the fourth quarter is 6732 tons. So clearly the fourth quarter is more than the third quarter. So we can write 29T minus 26T gives us 6732. This is 3T. So 3T will be equal to 6732 by 3. 3 2s are 6, 2s are 6, 1, 3 4s are 12, 2 2 4 4. So we can essentially find out the value of T is 2244. This would mean the total is 100T, which is 224400. Although this is not something that we need to calculate here, but it's good to know. What is the difference between the production volume of the first and the fourth quarter? Okay, so the first is 20T, the fourth is 29T. So essentially we need to figure out 29T minus 20T, which is equal to 9T, or 9 times 2244. This will give us, okay, so the answer should be 20,196. So option D should be the correct answer here. I hope you guys understood this. It was a little difficult from the previous one, I would say, but this is the kind of thing that might actually come in the exams, right? They will not probably ask very direct questions like the previous two. This is also somewhat direct, just like a little bit you need to know, right? Ayati, we didn't assume the quarter, we calculated it because the quarter one should be, because as I said, the total is always 100, so you just subtract the 100 from it, right? Most of you answered, Bhavana, don't know, Rishabh, Joshua. Great, great. You guys got the correct answer. That's really great. Now let's move on to the stacked bar graph. Now, this is something which can be a little bit difficult to read at times. What it means is it's like combining elements of the pie chart and the bar chart to make something the stacked bar chart. So, what we have in normal bar charts is that we have different columns for like different attributes, right? Like this one, no, this one we read key, like see, XYZ and ABC, two different companies, we have two different bars for them. In case of a stacked bar chart, now instead of doing two different bars for one particular year, we have one bar only for 1 year, and that bar we are dividing into parts. Like instead of writing say 2016 May, say this is 10 and the other one is say 15, we'll just make one bar of 25 and we'll put a mark like this. Like this is one color shaded, this is some another color, which tells us ki the two are different measures for difference. Instead of like putting them in two separate bars or buildings, we just put one building where we are like doing different colors. It can be 2-3 things, right? So different colors essentially highlighting different things. Let's look into a bar chart, stacked bar chart. Yeah, so yeah, one more thing about bar charts though, they can as I discussed, they can be something horizontal or they can be something like this also, vertical. Doesn't really matter, we can read it nonetheless. So here the following bar chart shows the sales of 3 product types across 3 regions. So we have the north, the south and the west region, and we are given 3 products, product A, B and C. So how do we read this? Let's put north here, the south, and we have west. of product A, product B, and product C. So for product A, for North, the value is 25. Because see, this is 25, so you just draw a direct straight line. So this is 25. For B, this is somewhere in the between here, right? The chart is not very detailed here, but one thing we understand that if it's 25, so it would mean ki, like, if we divide it into 5 equal parts, then this is 5, 10, 15, 20 and 25. So this would be somewhere around 20. So for South company A, we can have a 20, and if this is 25, let's say so this is a little bit more than 25 though. So essentially like that we can read it. Let's say for chart for product B in the North region, the total is again here 25. So if we divide it into 5 parts, it essentially looks like this is 3 parts and this is 2 parts. So this has to be say 15 and this has to be 10. So 15 and 10. Although this chart looks a little bit ambiguous, but obviously for exams we will not have charts like this. They will be very well detailed. At least they will have all the data points that we will need to calculate our questions as such. Here like this one, we can assume that it's little bit above 25, so it will probably be something around 30, because it's not as big as this, but like a little bit big, right? So this should be somewhere around 30. So like that also we can infer, but obviously during exams we'll have a much more detailed chart. Okay, so this is 50, this looks like a 10, and if this is 20, that would mean if this is 50, so this entire portion would probably be 40, and this will then be around, let's say, 3 parts, so like 30. So like that we can figure out. One more thing about stacked bar charts is they can also be expressed as percentages of 100. Like instead of putting direct values like this one, instead of direct values, they can essentially express this as percentages also. And what is the thing when they express it in percentages? The total is always 100, right? So here if you see A, B and C, we understand the total is 100. So that would mean for North in A, B and C, for North it's 50%, for product B it's a little bit more than 75. So 50 to let's say this is 80, right? So this will be 50 to 80, which is 30%, and the remaining is 20%. In this case though, we kind of had an idea about the absolute values, because we understood that this total is 100, this total is like more than 175, this total is somewhere around between 50 to 75, so this would be somewhere around 70 or something, so somewhere around 60 or something. So that is the thing. In case of when it's given as direct values, we can directly have absolute values, but whenever it's given as percentages, like in a stacked bar graph or in a pie chart, whenever it's given as a percentage, the question will supply us with the total. And if the question does not supply us with the total, we'll assume it to be 100t or something like that, because they will not keep totally hanging. They will give you some constraint, like we saw in the pie chart thing, ki there will be some constraint given to us for us to essentially figure out what the total is, so that based on that we can go on figuring out the other values as such. So yeah, this is it. I don't think you guys have any questions about this. If you guys have, please put it in the chat box. Okay, no text as such. Okay, now let's then move on. Next, we have one question on stacked bar graphs. It's not very simple. Try to figure it out. It's not very easy. It's not very difficult also. You guys can figure it out, I'm very sure. So, all the best for that. Do note that the bars look of the same height, but the total is not 100 or 1. So it means ki they are probably given as absolute values or like percentages also, but it's not total percentages. So keep that in mind. Okay, let's look into this question then. It says bar chart represents the composition of mixtures made up of 3 liquids given in liters. Mixture 1, 2, 3 and 4. Oh, they are made up of 3 liquids: alcohol, water and soda. So mixture 1 has, let's just write it down like that. 1, 2, 3 and 4, and the components are alcohol, water and soda. So see, one thing we notice here is ki although the bars are of the same height, but we are told ki represents the composition, which means the percentage in the liquid, and the total is also not 100. So these are not direct percentages given to us. So here we can assume that if this is x liters, mixture 1, let's call it x liters, we have x liters of it, then we can say ki like all of them have like different quantities. Like if mixture 1 is x liters, then the amount of alcohol in mixture 1 will be 10%, right? So that is one thing. But here when we look at the chart, we understand that they have given us direct values only. They have given us very direct values. It looks like a stacked bar chart where it has been expressed as percentages, but it's a very direct value thing. So for mixture 1, we have here, which is 1. Water is 1, 2, 2.5. And soda is 1.5. Okay, 3. So the total is 6.5. So essentially it means that mixture 1, we have, if we have let's say 6.5 liters of mixture 1, that would mean in it 1 liter is alcohol, 2.5 liters is water and 3 liters is soda. This is not given as a percentage, rather this is given as, you can call it to be a ratio. Like if the total was say 13 liters, then we would say the alcohol is double, which is 2, the water would be double, which is 5 liters, and the soda will also be double, which is 6 liters. So here instead of percentages, they've given ratios. That is the thing, whenever you are doing data interpretation kind of charts, essentially, You need to be very good, or like, at least have a decent idea about how to calculate percentages, all these questions in percentages, a ratio, proportion, averages, mixtures and solutions, all those kind of questions, because the calculation part in DI na is essentially mostly those kind of things only. So you guys, if you haven't checked it out, we have provided the videos for them as well. Go check it out, brush up your concepts, then you can come back and watch this again. For the mixture 2, let's get back to the question now. For the mixture 2, alcohol is 1 to 2.5. Water is 1.5. Soda is 1 to 2.5. Again, see, it's a 6.5. Okay, like all of them are 6.5 liters only, we can assume, because the total, the ratios are given to us. So if we and the question asks ki the mixtures are mixed in equal proportion. So all of them we are taking equally only. So if all of them, let's say we are taking 1 liter, 1 liter, 1 liter, then the ratios would also follow that. For the third mixture, we have alcohol to be 1 to 3, water to be 1.5, and this to be 2. Again, it's a 6.5. And for the fourth mixture, we have alcohol to be 1.5, water to be 1, 2, and this is 1, 2, 3. Again, a 6.5. So now the question asks, if each of the mixtures is mixed in equal proportions, we get mixture 5. Then what is the ratio of water to alcohol? So we need water to alcohol if all the 4 mixtures are mixed in same proportion. So this is very important here, because they have said ki, like, they are mixed in equal proportion. Therefore we can assume ki all of them are 6.5 only they are given. The ratios essentially hold true, they are constant here. So that is why here for water we can say ki, like, if all of them are mixed together, the amount of water will be 2.5 plus 1.5 plus 1.5 plus 2, which gives us a 4, 5, 6, 7, 7.5. And the alcohol content would be 2.5 plus 5, which is 4, 5, 6, 7, 8. So the ratio will be 7.5 by 8 or 75 by 80, which if we reduce, we'll get 15 5s are 75, 15 6 are 80. So 15:16 should be the answer here. Right? Any questions on this? Yeah, Bhavana and Rishabh got it correct. Anusha, I think you read this equal proportions and you thought ki, like, the alcohol and water mixed is equal. That is not the thing. The thing is, the mixtures are mixed in equal proportion. And don't know, probably you did some calculation mistake here and there. Nonetheless, good attempt, guys. Let's move on to the next topic now. Okay, so we have something called tables with missing values. So we have understood what tables are. So in case of tables with missing values, it's pretty simple. They will give us some values, let's say 25, 30, 12, anything. They'll give us some values, they will not give us some. And the values that they will not give us, they will provide us with clues for us to essentially find out what these values are. So it's just like that. It's like an amalgamation of DI and LR, where you have to use some clues to essentially figure out what these values are, and then using those values figure out the rest of the questions. So we have a question now for tables with missing values. It's a fairly simple question. Give it a try. Look at the clues. Try to attribute variables. Whenever you see, let's say in this table only, if we find that there is a relationship between this one and this one, and this one and this one, let's say all 3 of them are related by some logic that they have given, like one is the double of the other or something like that. Tabhi best is, attribute a variable to it. Fill out the table with like attributing variables. Then you will see ki okay, some variables like, let's say this is the double of this and this is like the half of this. So this is the x by 2. And then again, if this is m, somewhere we find a relation ki this is m, then this is 4m. So this will tell us ki 4m should be equal to x by 2. You might miss something like this if you are not actually making the table and filling in the values. But if you are making the table now, you will see ki, okay, this value I have taken to be m, this is 4m, and this same cell we have also found it to be x by 2. That would mean m is what? X by 8. So now instead of writing m here, we can just convert it to x by 8. That way, you'll try to figure out like if all of them we can put it in one variable or two variable or three variables. And then there will be other constraints like the sum of the total is this, or like, if you take an average of these three, you will get this, like some kind of a constraint they will provide. Using that condition, we can find the values and then we can fill out the table essentially. That is how you essentially go about approaching these table with missing values ke questions. Um, the best way to understand DI in my opinion is to do a question, because अभी तो मैं like हवा में बोलेगा आपको थोड़ा समझ आएगा, something you will understand, something you won't understand. If I show it in a question, you have a better chance of understanding. So let's move on to the question then. I'll just remove this. Ryan, if the totals are different for different values, तभी we will have to convert it. In that case, let's say one of them had 6.5, another ka total was 7, and then we are told that they are mixed in 1:1 ratio. Then we would have to, then they would essentially give us the total values. Like 6.5, instead of giving 6.5, they would give us like say 650 ml. So तभी we will have definite values. Uh, and if we have definite values, then we can like just normally add them up in some ratio, whatever ratio they have told. This is like a concept of mixtures and ratio proportions. So you can like go check out the videos there. There they will obviously have explained it in much more detail. So I think that will help you understand this better. Yeah, I'm sorry. Yeah, there has been some error. Not sure why this is happening. We are showing as a group, showing as like an individual question. No, this is a group question. Three questions here. Here they are written as group only, but in the screen it's showing as individual question. I think you're correct actually. Joshua is also correct. This is actually a group question. So these kind of questions essentially, they have, one set, like this is a common bit of information, and there will be like 3, 4, or 5 questions that follow. So for some reason, the group is not being displayed like that. So that is the issue here. But anyways, okay, let's just try and fill out this table, because once you filled out the table, the questions are easy cake. Okay, so let's read it. So we are told that the quiz part is AT&T College organized the Tech Fest with 3 events: coding, robotics, and quiz. The table below provides the partial information. Okay, so we are given some of the data values. We are not given all of them. We are told the following additional clues are given. So we have to essentially figure the table out using these additional clues. Just use a color that's visible in both. Yeah, okay, this works. So here we are told that the quiz participants from ECE are 2 more than half of the robotics participants from CSE. So if we take the robotics participants from CSE to be X, then the quiz participants will be 2 more than half of it. Half of it is X by 2, 2 more than is half of X by 2 plus 2. So the quiz participants in ECE will be X by 2 plus 2. Similarly, the coding participants from ECE are equal to the robotics participants from mechanics. Coding participants from ECE is, let's call it Y, that is equal to the robotics participants from mechanical. Robotics mechanical, this is a Y. The quiz participants from civil are 5 more than robotics participants from CSE. So see, robotics participants from CSE were taken it to be X, then the quiz participants from civil are 5 more than that, so that should be 5 plus X. And finally, the coding participants from civil are 2 less than the coding participants from CSE. So the coding participants from CSE, this is given to be 32. So that would mean कि civil का is 2 less, which will be 32 minus 2, which should be 30. So this we have here is a 30. Now we'll just try to figure out rest of whatever it is. One thing we see here, कि if you look at this row, the civil wala row, here we have the total is given to be 87, as in 87 people participated. So this should mean कि 30 plus 28 plus x plus 5 should give us an 87, right? So this would mean कि x plus 5 is equal to 87 minus 30, which is 57, minus 28, which is 29. So this x plus 5 should actually be 29. And if x plus 5 is 29, that would mean x is equal to what? X is equal to 24. So we figured out x, this should be equal to 24. And similarly, this x by 2 plus 2 should be 24 by 2, which is 12, plus 2, which is 14. So this should be 14. We figured out a lot here. Next, again, if we see the ECE wala column, here we will have y plus 20 plus 14 should be equal to 60. This should give y is equal to 40 minus 14, which is 26. So if y is 26, then we have all the values filled in, right? Now this row also we can sum up. 26 plus 30, 56 plus 25, 66, 76, 81. And this is what we asked, na, कि the total number of participants in the mechanical department, that should be 81. So if you figured out this table, then you can eventually figure out the next question also. It should be this. The number of total participants across all the departments in the quiz competition. So if we figured this out, okay, so across all the departments in the quiz competition should be 18 plus 14 plus 30 plus 29. This should give us 30, 30, 60, 78, 88, 89, 90, 91. So for this should be a 91. And similarly for the last question here, which is the percentage of students from CSE who participated in the robotics event as a percentage of the total number of participants. So what was the number of students from CSE who participated in the robotics? 24. CSE who participated in robotics is 24. And what is the total number of students? We are asked to express as a percentage of the total number. So the total number of students is, okay, we need to figure this out also. So 32 plus 18 is 50 plus 24, 74. So the total is 74 plus 60. Is 302. So the total number of students who participated, we found it to be 302. So for this question, which asks us ki the total number of students who participated in CSE as a percentage of the total number of participants from all the departments. So this should be 24 by 302 times 100. So 24 this we can calculate, but see, they've asked is total number is closest to. That would mean ki we do not get a very direct answer here. That would mean we need to use the calculator here. So, matlab you can obviously divide yourself, but I prefer to use a calculator in these situations because they most probably have, like, very recurring something. So it's 2400 divided by 302. This gives us 7.947 something. So 7.95. So option B should be the correct choice here. So this is essentially how you figure out how to do tables with missing values. Yeah, Navja, you are correct in both the cases actually. Today's class was on basics, Shrey Sharkar. So probably the actual questions might be a bit harder than this. These were very basic questions. There is some issue with the interface. I'm not sure exactly why it is. So we'll probably be ending the class here only. If you guys have any questions, you can let us know. Yeah, the questions are expected to be a bit tougher than this because today's class was just, introducing you to the basics. So we did that. When is the next class? The next class is tomorrow. Tomorrow, same time, 8 to 9, we'll have the class. Tomorrow's class, we are covering, I think, matrices and determinants. Okay, if there is no other questions as such, then I guess I'll just end the session today. Thank you all for tuning in. I hope you guys understood whatever was discussed today. We'll probably have another class on DI where we will discuss a little bit harder classes, little bit harder topics as such. The schedule will be updated. We'll give an update on the WhatsApp group, the community group that we have. So you'll get all the updates there only. Yeah, we plan on doing it actually because today's class was cut short. I had two more sets which were, like, a bit more difficult, but those we will not be able to discuss because of the interfere issue. So okay, sure. I'll post them in the group. You guys can give it a try and yeah, get back to me. Like if you have any problems as such, unable to figure out or anything, that's actually better. I'll post it now only. The WhatsApp group that we have for IIM Bangalore UG, IATI, there we essentially share all the important questions or anything related to updates, essentially, whatever you need to know for the IIM Bangalore UG, you can join it there.